Okay, so now I want to show you. I'm not satisfied with this pen. Oh well, it doesn't matter. Oh, can you hand me that one that's on the top? I want to show you a different way we could think about it, and in a way that we thought about it the first time around, with just the one row. Okay.
Okay.
Where we could define a rectangle by sort of its upper left-hand box
Yeah.
and its lower right-hand box. That would be one way to define a rectangle, right?
Yeah. Mm-hmm.
What would be another way? And how many ways are there? Well, what would be another way to define this rectangle if we were
Well,
going to define it by corners?
If you look at it like this,
Yeah.
one right in the
We
corner.
could look at it like this.
Yeah.
Okay. So what we end up having to do here is kind of asking the question, how many choices do we have for this corner and this corner? And then there's going to be a mirror image.
So you have to divide at the end.
Yeah, we're going to have to divide at the end, and we're not sure by what we're going to have to divide at the end. But how many points do I have in my grid? If I go back to the example we had before, it's 4 by 3.
20, I think.
5 by 4.
5 by 4.
20 points. You can't have these 2 points on the same row.
Yeah, so I've got 20 points, 20 choices for the first point.
And
We have
then
19. Well, yeah. We don't want to if we choose the same point, then we're gonna have problems.
Okay, so we don't want to choose the same point.
So then there'd
So
be 19
I've
points.
got 19 choices for the second point.
But some of these choices won't result in a rectangle
Some of these choices are not going to
ones
result.
on the same row.
and the same column.
So once I choose my first point, I've got all the points in the same row. So we've restricted ourselves. We can't choose this point again.
And then we have 1, 2, 4 other points, and then we have 7 other points.
Okay, and so I would have to subtract all the times that we didn't get a rectangle, which is -7 times what? How many times
Well,
did we have to eliminate 7?
20 times.
20 times. For every choice, there were 20 things we had to eliminate. Right?
Yeah.
Yep.
So 20 times 19, remember what the answer was from before? It was 60, right?
Yeah.
It was 5 choose 2 times 4 choose 2. This is not
That's 20 times 12, right?
obviously 60, right?
Yeah.
In fact, it's definitely not
It's-
60
it's not
because it's
60.
20. How did you know so quickly it was 20 times 12?
Because I can factor to 20, and it's 20 times 19 minus 7.
Okay. And now, so here's the challenging question. For every rectangle, let's go back to the rectangle we had initially. I can cover it almost with red rectangles. That's 3 reds and a purple. How many times, I want you to tell me because I think you know, how many times did I count this rectangle here? When I chose the first point and then I chose the second point and eliminated the ones where I didn't have a rectangle. How many times did I count this rectangle?
Well, you can choose the upper point and lower point. It's 1.
Uh-huh.
You choose this point first. You can do that,
Yeah?
and then you can do cross, up, down, and then down, up. So 4 times
Okay, so I got 20 times 12,
all over 4.
Which
All
is
over four.
60.
60.
which is 60.
Yeah,
So this was a completely different approach.
but it gives the same answer.
Well, and that gives us confidence that our answer is right because we counted it 2 different ways and we got to the same answer. And it's a
Yep.
surprise, right? This is a fun surprise
Yeah.
that these 2 different ways of counting here produce the same number of rectangles. What was the first way? What was our first approach?
So we selected 2 rows, and from those rows we selected 2 columns.
Okay, so in the first case, we said a rectangle is going to be defined by the columns and the rows that it's on.
Yeah.
So I got to pick the columns and then I got to pick the rows.
Yeah.
And that gave us 5 choose 2 times 4 choose 2.
Yeah.
However, there was another way to identify the rectangles, which was what?
Which
By
is
the corners.
the opposite corners.
By the corners. And then we had 20 times 19 ways to pick this corner first, this corner second.
And then
We subtracted away the ones that didn't produce
the-
rectangles. And then we had to realize that we counted every rectangle 4 times.
cool approach.
So 2 very different, seemingly very different approaches. But once I get to like a 31 by, I don't know, what, 42 rectangle, this approach might be a little complicated just with the numbers. Our old approach, if I had a 31 by 42 rectangle, what is the number of sub-rectangles?
Well, it's 32 choose 2
32 choose 2?
times 43 choose 2.
That's 42.
And you just have to work that out.
This
Yeah,
would
whatever
be
that is.
simpler for large rectangles.
Yeah. But for learning how to count things, these 2 approaches are really interesting.
Yeah.
All right, high five, guys. Good work tonight.